All right, do you have questions about your homework? Yes. 37. All right, guys, we have switched gears and we are now on homework. And we are looking at number 37, which was used completing the square to change the form. So I have f of x equals 2x squared plus 6x plus 7. And so I am going to take the leading coefficient out of just the front two, which leaves me with x squared plus 3x plus 7. And so now I'm going to find that good C that makes a perfect square trinomial. And so that is half of 3 squared, which would be what? 9 over 4. So now I have 9 over 4 here, but when I subtract it, what do I need to subtract? 9 over 4 times 2, right? Because I need to make sure that I multiply by that number that's out front. So 9 over 4 times 2 would be 18 over 4, which is actually 9 over 2. You still have to factor it out by dividing. I'll do that one if you show it to me. Show me when you come up. Let me finish this one and then I'll do it. But be looking at that one. All right, so I'm going to take my calculator and I am going to do, and if you do 7 minus 9 divided by 2, and then you hit math, enter, enter, you'll be back in fraction form. So this would give me 5 over 2. So I have 2 times the square root of x squared is x. I take the first sign, and the square root of 9/4 is 3/2 squared plus 5 over 2. So what is the vertex of this problem? Negative 3 over 2, 5/2. And is it skinny or wide? It's a vertical stretch, which means it's going to be skinnier, right? And that's it, right? Vertical stretch of 2, yeah. Well, you would, so before you start on that one, you factor out the negative. So what you're going to do, I don't know why I can't. And I'm going to go ahead and change this one around. Negative x squared plus 8x plus 3. So you take the negative out. X squared minus 8x plus 3. So really that's a negative 1 in front, right? All right, so my good C is going to be 8 over 2 squared. So it'd be 16. So I'm going to do x squared minus 8x plus 16 plus 3. And here I'm going to do plus 16. Yes, because, yeah. Because it's minus negative 16, which is plus 16. Yeah. Okay. Charlesie, which one? 32. H of x equals negative 2x squared minus 7x minus 4. So again, I'm going to take the negative out, the leading coefficient out, so it is negative 2, and that's okay. X squared, I'm going to change that to plus because I took out a negative, but I can't divide 7 by 2 evenly, so just write it, 7 over 2. It makes finding your C a little bit harder because your C here is going to be 7 over 2. Instead of dividing by 2, I'm going to do what? That's right. So 7 over 4 squared would be 49 over 16. So I end up with h of x equals -2 times x squared plus 7 over 2x plus 49 over 16. And again, because I'm subtracting a negative here whenever I multiply, I'm going to actually add it instead of subtracting it. 49 over 16 times 2, math inner would be 49 over 8. Because I'm doing minus negative here. Minus, and it would be, that would be negative 49 over 8. Yeah. -2, this would be x plus square root, squared, and then again, I'm going to put this on my calculator. -4 plus 49 over 8, and I'm going to do math inner. 17 over 8. So you do the square root of this one, the first sign, and the square root of the last one. Lily, which one did you say? 38. Let's see. So we do g of x equals 5x squared minus 25x plus 12. So I'm going to take the 5 out of the first two. Leaves me with plus 12 here. And now I'm going to find that good c. So half of 5 squared, which is going to be 25 over 4. So I get x squared minus 5x plus 25 over 4 plus 12 plus, is that 125 over 4? Oh, minus, I'm sorry, not plus, minus. Okay, so you always subtract, because what you're wanting to do is offset on the same side of the equation. Now, if I was going to different sides, I'd do the same thing, but because I'm on the same side here. So this would be 5 times x minus 5 over 2 squared. And again, I'm going to use my calculator to do this, but I'm going to keep it as a fraction. So 125 divided by 4, 12 minus that, math inner would give me negative 77. What? Yeah, I mean, you can use it for doing, if I was doing math like this, combine the fractions, I would use it, yes. But as far as, it's technically, what number is this? 38. This is a calculator problem. Oh, yeah. What else? Anybody? All right, y'all ready to talk about today? Probably tomorrow, since we're finishing this section today. We've just been through section 1 since your test. So we started with the linears, moved to the quadratics. This is our third day on quadratics, isn't it? Is this the third day? No, this is the second day. We're doing the word problems for the quadratics today. So should I just like I would. We were supposed to do it all yesterday. The plan today is that you have classwork instead of homework, because we're kind of a day behind on what the heck. Give you some. So don't forget we started this with, remember the scatter plots and the linear regression on our calculator, right? Writing those equations of lines. Just want to make sure that you remember where we went. Everything. Let's see. So let's talk about applications. We did this in Algebra 2. I don't know if you guys remember. Just before we jump right in, most things with quadratics that you're going to be given, and most of the time you're given an equation here, most of the time what we're doing is we're looking for maximums or minimums. Where might the maximum or minimum of a quadratic occur? The vertex. So in other words, we're looking at the vertex. If I'm asked for the maximum value or the minimum value, so if you see the words value or most of the time that's what it's going to say, or maximum height or maximum, most of the time what you're looking for here is your y value on your, the maximum value of the function. We're talking about the y. If we're talking about where it occurs, that's my x value. I'm just trying to think about some ways because y'all said you don't always know how to interpret when it's given in a word problem what exactly it is they're asking for and what you're looking for. You will have some gravity type problems. Those are typical quadratic problems. You'll probably be looking for things there other than maximums or minimums. You might be looked for where it hits the ground or looking for where it hits the ground. If you've got a quadratic that is modeling, say, you throwing a ball in the air, and the height is modeled by a quadratic. If I'm looking for when it hits the ground, what am I looking for? The zeros. Okay, do y'all remember doing this? Okay, well, clearly it's not too hard. Because if I think about this ball being thrown this way and it starts here, then the place it ends here also. Where it hits the ground would be the other zero of the quadratic. All right, so let's do several examples. And then I'll give you a classwork assignment. No, you'll just have classwork, I think, today. What time do you get out of here today? 11:40? 25. What? I mean, I might let y'all finish. Third block's definitely going to have to turn in before they leave. Because I can't make them. Because this was just a piece that I was supposed to get through yesterday and I didn't. And rather than jumping into the next lesson too and I never mind that as long as everybody's working. Yeah, as long as everybody's working. The point, like yesterday, my third block, they would not work. I kept saying work, 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 and they would not work. And we finished 30 minutes early in there, and they would not do their work. So they're going to turn in whatever they get through today before they leave. All right, so let me do some from examples from your homework, I think. Oh, this is a good one. This is number 54. I hate to do this one with you because it's such a good. Let me just help you set it up. Among all, this is one that doesn't give you the equation. That's why this one's a little bit harder. Among all the rectangles whose perimeters are 100, Find the dimensions of the one with the maximum area. I think about you every time I get ready for a word problem, Alex. Okay, let's think about this. Among all rectangles, any rectangle in the whole wide world, whose perimeters are 100?
So like the sides are.
Yes. So maybe I've got a rectangle that's 99 by 1, and then I've got another rectangle that's 45 by 55. So all rectangles, or no, I got that wrong because that would be, right. But you see what I'm saying? They're going to add up to 100. So maybe this one is 20. 20 is 40. That would leave, so 30. Okay. All right, but they could be varying. So every single rectangle in the world whose perimeter adds up to 100. So for all those rectangles, find the dimensions of one that has a maximum area. Okay, so let's think about this. Area is length times width. What is perimeter? Okay, so length plus width plus length plus width. So maybe I could even say 2 length plus 2 widths. Are we all okay there? If you know, and let me just write the problem, maximize area. So this kind of problem might be written something like the way I've seen it in previous Algebra 2 books. You have 100 feet of fencing, and you want to build a garden that maximizes area. What should the dimensions of your garden be? This is what we're looking for, because perimeter would be how much fencing I have, right? And I want the most area inside, so what do I need to make my sides be? So to do this, what I want to do first is only have one variable that this is written in. Do you agree with that? I've got too many variables here. Okay. How could I write perimeter? Because perimeter is really what I know. Perimeter is 100, right? How might I be able to write perimeter using only one variable if I know that it's got to equal 100? Okay, so, but x may not be the same. Yeah, what you got, Abby? Okay. 2x plus, did you use x and y? Is that what you said? Okay, that's fine. 2x plus 2y. Set it equal to 100, and then you solve for, what'd you say, y? Okay. Why'd you do that? So maybe you did 2L and 2W, but she's saying this is my width, this is my length, right? But these can vary. But what I do know is whenever I do W plus L plus W plus L, I'm going to get 100 every time. Okay? So now what she did was she said she solved it for y. And that's exactly what I would have done here. Move the 2x and divide by 2. Okay, so I get 50 minus x equals y. Would you agree with that? Would you agree that no matter where I am on here, if I take 50 and subtract out the width, I'll be left with the length, or vice versa? Okay? So now, if I write my sides, instead of, and we'll call this x and we'll call this y. It doesn't really matter which one you let be which. Would you agree now that really I could rewrite this as 50 minus x? Because that's what it means. If I have 100 to use, right? I just solved it, essentially is what, okay. I'm trying to find the maximum area. So what I need to do is I need to use the perimeter given so I can only get in one variable. Because remember, area is length times width, right? Or x times y, whichever variable you used, it doesn't matter, okay? Now, using these same variables, what would the area of any rectangle with perimeter of 50, with perimeter of 100, any rectangle with perimeter of 100 would have the area of what? Not plus, but times, right? Does that make sense? We said this is x, and we said this is 50 minus x, so to find the area of that rectangle, I'd multiply the two together, right? Okay. We don't have area, but we're not trying to, what we want to know is what would the dimensions of the rectangle need to be in order to have the most area we could. Say again? We know the perimeter is 100. We were told that in the beginning. You only have 100 feet of fencing. Well, the 100, you will. You will. Because look what happens with the area. The area here is 50x minus x squared. And we're letting x be one side, right? How could I find the maximum of that? Yes. Find the vertex. Maximum is always vertex. So if you have a quadratic equation that's negative x squared plus 50x, how do you find the vertex of that? You could put it in vertex form. What else could you do? Negative 50 over 2 times negative 1, which is what? What do the dimensions of my rectangle need to be in order to maximize area? 25 by what? If x is 25, y is 50 minus 25, which is, so I'd need it to be 25 by 25. I'd need it to be square. Is a square a rectangle? Is a rectangle a square? A square is always a rectangle. A rectangle is not always a square. But it would be a square, but that still satisfies because the definition of rectangle is opposite parallel sides, or opposite is all four equal sides. Right. Yeah, this one was tough. But here, the point is here, as we maximize things, we're looking for the vertex. Well, that was the word from the book. Okay, let me read it. I read it to you, but you didn't. It's really one sentence, and it was tough. That's fine. Okay, so it's number 54 in your book. It says, among all the rectangles whose perimeters are 100, find the dimensions of the one with the maximum area. That's it was a tough one. That was a tough one. That's why I wanted to do it.
Really fun.
How are you? I'm good.
So would the area for that one be 625? Would you 645 times 25?
Let's do 61. If you have your book and want to follow along, page 165. So, we are going to, before I give you this one, let me give you the free fall equation that you will be using for these type of, and I'll give this to you on your test as well, or your quiz if you need it. Yeah, this is to do a problem like this. This is the free fall equation, and I'm going to tell you what all this means. This looks like physics, I'm sure. Have y'all done physics yet? Yeah, I'm going to tell you. This is, no you don't, no you don't. This is height. So V sub 0, anytime you see it like this occurs all the time. From this point forward, you'll see it in your science classes, you'll see it in your math classes. This just means initial velocity. This is in your, yeah, these are in your book, but no, I'm giving you this. G is always 9.8 meters per second squared. So you could even plug that in here if you wanted to. There's your G. It's going to be a word problem. All right, let me do some explaining on this for your, but y'all are looking so stressed. Don't be stressed. It's just plugging in. It just looks worse than what it is because of the variables that are being used, okay? This is saying if you drop something off of a cliff or you throw something into the air or any of those things, gravity takes effect, right? So how fast does it fall? So what it's saying is your position after t seconds, okay? S of t is your height or your position. Is going to be, you're going to use this equation. You'll plug in 9.8 for g because that's gravity. Y'all should have heard there was 9.8.
Some very great.
Should have had that in science.
We never took regular science.
We take in biology and then like most people who drop maybe 10 or 2 physics. So that's not in our schedule.
Where did you learn it, Abby? What class? How are you? Talks about what?
Yeah, he also said there was like a World War in 1960. Yeah. And Brett were like, no.
Wait, who said that?
Our teacher said that the British invaded.
I just feel like every year I get y'all, there's more and more. There are more and more holes that y'all have that you shouldn't.
We won't even take it. We should take it by. We won't even have it.
I'm not taking that. No, sir.
We'll never even touch it. Yeah.
Anytime you see a sub-zero, that indicates to us an initial value. V is always velocity, S is always position. Okay, we'll do a lot next year in calculus with position and velocity because, well, we won't even get into that. But initial velocity, initial position.
Wait, I thought it was
Position height. Okay. where you start. I dropped it from 5 feet above wherever you start. Okay. Um, T is your seconds. That's your variable, just like your x. Okay. Y'all okay right now? Those are the two equations you need to know. You don't have to memorize them, but at least be familiar with them to know what plugs in where. Okay. Um, just in case you needed it. 9.8 meters per second squared is the same thing as 32 feet per second squared. Y'all haven't heard the 32 either? Yes, that's the gravity force, the force of gravity. Wow. Y'all, that makes me rethink some things. That's not true. Number 61 says, as a promotion for the Houston Astros downtown ballpark, a competition is held to see who can throw a baseball the highest from the front row of the upper deck of seats, 83 feet above field level. The winner throws the ball with an initial velocity of 92 feet per second and it lands on the infield grass. Find the maximum height of the ball. All right, so there's a lot of words here. Are you okay, Alex? Okay. A lot of words here, but we're going to pick and choose what we need. All right, I don't need to know about the promotion. I don't need to know about any of that. I do need to know that I start out 83 feet above field level. And the winner, so what do you think that, first of all, what equation do you think I'm going to use if I'm wanting a maximum height? I want a maximum height, I'm going to use the height equation. 61. Exactly. My initial, where I start is 83 feet above. He's not at ground level, he's starting out 83 feet above because he's in the stands. Does that make sense? Okay. I think you have. I feel like you have to have seen this somewhere. All right, this is gonna be my initial height or my starting height. Okay. And then it said, all right, so let me read it one more time because I want to make sure you can interpret this also. As a promotion for the Houston Astros downtown ballpark, a competition is held to see who can throw a baseball the highest from the front row of the upper deck of seats 83 feet above field level. Okay, so all that, the only thing I needed from that was 83 feet above field level. The winner throws the ball with an initial vertical velocity of 92 feet, bless you, per second. So that's my what? Initial velocity, right? All right. And it lands on the infield grass. Are you all with me? What is the maximum height of the baseball? The G is going to be constant every time. And in fact, yeah, you're just fine. Yeah. So yes, let's form this equation first. I know the equation I'm using because it asked me about a height. So I'm going to use the height equation. If it had asked me about a speed or a velocity, I would be using the velocity equation. Do you see the difference? Okay. So I've got negative 1/2. I know what G is, but I need to decide, should I use 9.8 or should I use 32? And why? Why? Because I'm talking about feet per second. That's the units that were given to me, so it's easier to use 32 than to try to convert that over to meters. All right? T squared, are you all okay there? Plus, no, my answer is going to come out in feet. All right, plus initial velocity. It's a quadratic. This will always be a quadratic. Okay? So the position at any point in time, because t is time, t is seconds, right? At any point in time, my ball is that many feet in the air. If I plug in a 2, that'll tell me how high up in the air 2 seconds after his throw my ball is. Does that make sense? Because this equation measures height. Y'all good? Okay. Well, that's not what it asked me. What did I tell you to find? Maximum height of the ball. Now think about this. This is a quadratic that's opening which way? Down, right? Maximum height of the ball happens at the vertex, right? How am I going to find the vertex of this? Okay. You can do either or, whichever you'd prefer. I think I'm going to do the opposite b over 2a this time for this one. You're absolutely right. You're absolutely right. Let's do that, and then we'll talk about what we're going to do. All right, so remember, this gives me my x coordinate. I'm not using x. I'm using s's and t's. So t equals opposite b over 2 times a. How I get what?
I got 2.875.
Say that again.
Is where I use the decimal.
T is in seconds, right? Yes, you can use a decimal here. Khalil, what was your question? Okay. Are we all okay there? Is that the maximum height of the ball? No. That's when the maximum occurs. It occurs 2.875 seconds after he throws it. You're exactly right. If it's easier for you to do that, then yes, you can. 61.
It's still the same one.
It's still, yeah. So Alex said, would it be easier if we put this in vertex form? I'll do it this way, and then I'll do it in vertex form also. We'll see which way's easier. All right, so now what I'm going to do is I'm going to do S of 2.875, which means I'm going to plug in 2.875 for every T. Y'all are right. We're not going to have time to do this in class. Approximately 215 what? This is not my book. The answers aren't in here. Somebody took my book and left theirs. It's devious. The new rule for what? Oh, one at a time with a pass, and if you're going longer than 5 minutes, we have to call for an admin to see what you are.
And they're coming in the bathroom.
What if you're just using the bathroom for 5 minutes?
Well, she said I can't remember the wording she used. If they're gone longer, something, I can't remember. I just assumed it was like 5 minutes.
They are.
Alex, if I put this in, what's not? It does 92, 23 over 4. Alex said, would it be easier if we put it in vertex form? And it could, I don't know. Negative 16 t squared minus 23 over 4t, and now I'm going to divide by 2 and square. Yeah. Oh, I did something wrong. I went awry somewhere.